All right, let's take a look at this question from the book here. This is on page 85 of the book if you want to check that out. And it says, which of the following quantities are scalars and which are vectors? So this is a little review. So see if you can do this. Go ahead and pause the video. All right, and so you should have said here for one, this is a vector. Acceleration can be positive or negative, right? Direction matters, which way you're accelerating. The number of passengers is scalar. The duration of the flight is scalar. Those numbers don't need direction. Displacement is a vector, and then the amount of fuel required for the flight is a scalar. Okay, let's imagine that you've made it to Egypt. And so you head off to Egypt with all your belongings packed on top of your van, and you get to the pyramids, and you want to know how much of a climb it is up the side of the pyramid. Well, how could you do that? Well, you could actually climb it, but without climbing it, you could calculate it if you knew the distance horizontally to the midpoint of the pyramid and then the vertical distance to the top of the pyramid. In essence, you would have the two component vectors, and this would become the distance up the side of the pyramid would become your resultant vector. So how does math like that work? Well, let's just give these numbers here. Let's say that for simplicity's sake, let's say that this number here is 115 meters, and the vertical distance to the top of the pyramid is 136 meters. How are we going to add these vectors together? Well, two little equations are going to help us, equations you've probably seen in math class. The first is the Pythagorean theorem, and this is for right triangles. And the second is the tangent function. And I'm going to add a third, and this isn't in the book, but I'm going to ask you to remember so, ka, toa. And you should know this is sine is the opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And if you need a refresher, if you had a triangle and you have this angle of the triangle, this side is the opposite side, the black side, the red side is the adjacent side, and the side opposite the right angle is the hypotenuse, okay? And so we can use SOHCAHTOA if we need it. So let's draw out these two vectors. We're going to be adding them together, right, to find this result. To find this resultant. So I'm going to write out my vector math. So it's going to be 115 meters. And I want to add these vectors tip to tail. So here's the tip, and I want to put the tail of the second vector here. So draw that straight up. And that is 136 meters. So now my hypotenuse of this is now my, what remember if we call this our resultant vector, right? So here's my right angle. Here's my right angle. So I've got the x and I've got the y, and I want to find the magnitude of this resultant vector. So adding two vectors together, we can use the Pythagorean theorem. And if I label these, this is side C, this could be A, and this could be B. And so using the equation, it looks like this. So to solve for C first, I'm going to plug these values into the Pythagorean theorem. So we've got 115, so C squared equals the x side, 115 squared, plus the y side, the y component vector squared. And this ends up solving to give us a distance of 178 meters. And so interestingly, when you add the vectors together, the answer will always come out greater than either of the two vectors, but less than what it would have been if you added them together directly. In other words, 115 plus 136, if you add these two together, that is greater than 178. So the vector always falls in between each of the numbers and what they add together to be. Okay, so it always falls in the middle there, somewhere in between what the vectors are and then what you would get if you added them together normally. And so this is where you would get 2 plus 2 not equaling 2 if you added a vector of 2 to another vector of 2. course, we're not done. This is just the magnitude of our resultant vector here. So we want to find the angle. So we want to find actually this angle right here. So I'm going to draw the little angle sign in there. We want to find that angle, right? And so to do that, I'm now going to invoke the second equation here, the second set of mathematical principles, and that's SOHCAHTOA, which tells us the tangent of this angle is equal to the opposite side, which is here, over the adjacent side. And so let me clear out this here. Okay, so what that's going to look like is we have the tangent of the angle is going to be equal to the opposite side, 136, divided by the adjacent side, 115. That's tangent, T, is opposite over adjacent, okay? And to solve this on your calculator, you're going to need the inverse tangent button, which on your calculator is a second function of the tan button. You can see there written, ironically, in tan coloring, is the inverse tangent function. And so you take the inverse tangent to solve this. And so the way it looks written is the inverse tangent of 136 divided by 115 equals what angle? And the angle we get for this is 49.8 degrees. Okay, so our final answer would be a vector of, and we don't know the east, west, north, south directions, so I'm just going to label this as 49.8. I'm not going to do the east of west or north of south, just leave it like this. So our final answer would be a vector. So C vector C is equal to 178 meters at 49.5 degrees. Okay, so this is our final answer for that vector. So we're going to start our practice here with number 3 from page 89. So if you want to fire up the ebook, there's actually 4 problems in this little section in the book, but this is number 3. So I'm going to first draw an amazing picture of this little girl, Emily. And so here's Emily. And she's awesome, and she's got black hair like that. And she passes the ball. And actually, I'm gonna put, just for us to practice, I'm gonna put coordinates here so we can get some practice. So she kicks the ball 6 meters across the field to her friend Kara, who is here. And Kara is a ginger, so she has hair like this, right? So the vector, the initial vector, is 6 meters in the east direction, and then Kara then kicks the ball 14.5 meters down the field to Louisa. So here we have Louisa, and Louisa is black, and Louisa has black hair. All right, so we have these two. So here we have Emily to Kara, and then Kara to Louisa. And the question is, what is the ball's total displacement as it travels between Emily and Louisa? So here's Emily and Louisa. What's this distance? So we're going to have to find the resultant vector. Now, if it said what is the ball's total distance, all you would have to do is add 6 to 14.5. The total distance is 20.5 meters. But we don't want that. We want the resultant vector. We want this guy. So we need to do our trig. So let's do our trig. Okay, so I set up the Pythagorean theorem. I've got side A, side B, side C. So A squared plus B squared equals C squared. So C equals the square root. So I get for C, I get a distance of 15.9. So the magnitude of this vector is 15.7 meters. Now, that's the magnitude. We want, and the unit, that's mu. We need D. We need the direction. All right, so let's find this angle here of the kick. So if this is the angle that we're using, this is opposite, and this is adjacent. So we're going to do the inverse tangent of 14.5 over 6, 14.5 meters over 6 meters will give us the angle, and the angle comes out to 22 degrees. And if this is east, then we are going south of east by 22 degrees. So this is 22 degrees south of east. So there is our direction. So our final vector C is equal to a vector of 15.7 meters, 22 degrees south of east. Okay? So awesome. If you like soccer, you love that problem. If you love physics, you love that problem. If you love soccer and physics, mind is blown. Physics is fun.